Welcome back, everyone. We had a request for Winter 18 Test 2 Part 1, specifically questions 6, 7, 8, and 9 in the multiple choice section, and those are referring to products W, X, Y, and Z. W, X, Y, and Z. So we got to take this whole thing from product 2 downwards here. Isopentanol starts off like this. 1, 2, 3, 4, 5. Product 1 will be isopentanoic acid, chromic acid oxidation, diazomethane esterification to make the methyl ester, and then we're in business. We don't need to use the dibal H, although that would make an aldehyde, and then a simple aldol, and then an aldol condensation product if you're trying to follow that one. But we wanted to go to W. LDA is going to be a directed aldol or Claisen, depending on what this is here, and that's an ester. So we're talking about a directed Claisen condensation. Product W looking like this. This lost an alpha H, made a new bond to this carbonyl of ethyl acetate. Carbonyl. And that is product W. And NaOH, product W, will take an alpha H that has a pKa of 10. And apparently we do need the aldol condensation product. I didn't look ahead. Product 5 comes from the aldol condensation product. So aldehyde. Aldehyde. Nope, not enough room up there. Looks like this. Aldol reaction product. I'm going to go straight to the condensation. 1, 2, 3, 4, 5. Double bond. Carbon groups CH2, C with a V. Isopentyl. 2, 3, 4, 5. That's product 5. We're going to add nucleophile to this position here. If it's a stable nucleophile, that's also a leaving group, and that is the case over here with W losing its H in step 1. Makes this nucleophile minus, which will attack product 5 in the manner indicated. So everything here stays. Get a new carbon-carbon bond right here to this position here. We'll do the rest all in baby blue. There's an isobutyl off there. There's also, comes to a C here that has a C aldehyde. Off the C with the C aldehyde is an isopropyl. That would be our product X. What was the ethanol for? The ethanol was for, after this addition reaction, we had an enolate right here, COO minus, and it protonated to get the H right here. So I know it's not really part of this question, but when you're doing mechanisms, it's good to know ethanol gave that. And that would be product X. Probably going to set up some kind of cyclization next. You're always looking for ring size 6 here, but right now we're not cyclizing. This is our rap song in code here. Saponification. My clue for you is the AQ with the hydroxide. I don't use that combination when I want to do aldol stuff. aldol reactions or aldol condensations. I put the AQ when I want to do saponification. It's just little whistle for you, a little dog whistle to tell you what to do. Now we want to make a ring size 6, and the only way from an alpha position to one of the carbonyls is right here. This is well, that's after we get to W. Y, so I can't even read the alphabet. We have to make Y first. Saponification, acidification, decarboxylation combination gets rid of this. Copy everything except that. Once again, this is X. Copy everything except for that circle. And we're going to go all with blue. And isobutyl and a carbonyl. And whoa, no, that's not what I'm looking at. Isobutyl, a carbon that comes down to a carbonyl. Same carbon has an isopropyl. You want to get ring size 6 when you see this combination from product Y. Z, we'll try to put Z right up in here. The only way to get to ring size 6 is 1, 2, 3, 4, 5, 6. One needs to be an enolate. And NaOH will take care of that. Aldol reaction product is followed by condensation here. So what we're doing for Z, ring size 6, I'll put the ketone on top. So right now I got 1, 2, 3, 4, 5, 6. And put your numbers on so you don't forget. 1, 2, 3, 4, 5, 6. Double bond between 1 and 6 for the condensation. 1 doesn't have anything else on it. 3 has, don't want this Y to look like part of a group, that's a Y. 3 has an isopropyl. 4 has an isobutyl. 5 has the carbonyl 6, and 5 also has an isopropyl. And we call this Z. And that takes care of that scheme right there. And we got other requests. Definitely going to have something like this on our test. Use this equilibrium for questions 14 and 15. I believe on your test, it'll be questions 9 and 10 and the end of the multiple choice. Diisopropylamine. Diisopropylamine. You might be thinking about LDA here, but that's really the conjugate acid of LDA, and diisopropyl ammonium is not LDA either. It's the conjugate acid of the conjugate acid of LDA. It's the conjugate acid of this is what I'm trying to say. pKa is 10. It's an ammonium ion. It even says in the name it's an ammonium. So this must be a base that's taking an H off of 4-oxo-5-heptanolactam. Which of these is a lactam? Let's just draw it. 4-oxo-5-heptanolactam. Heptanolactam. Lactams are cyclic amides. Off screen again. Lactams are cyclic amides. And we got to have the 5th carbon. The 5th carbon closes the ring on the nitrogen. There's 1, there's 2, there's 3, there's 4, there's 5. That closes the ring. And we got to go to 7, 6. Wow. 6, 7. And this is everything except for the 4-oxo. That is 5-heptano lactam. It's named after what it was before it closed the ring. 1, 2, 3, 4, 5, 6, 7. Yeah, heptano. Oxo, position 4. 1, 2, 3, 4. 4-oxo. Carbonyl right there. So the carbonyls are across from each other in a ring size 6. Got rid of 4 choices. Pretty nice, huh? Which one we're going to take off first? If you had to guess the pKa here, that's a carboxylic acid derivative alpha. And the only one you know so far is esters. Amides, I'd have to say, are roughly the same. And this position here is just alpha to a ketone. Some of you are looking to deprotonate here. Some of you are looking to deprotonate here. Oh. And yeah, we do have a request for new pKa's, and we got like 2 of them here. Alpha to carboxylic acid derivatives, 25. Amides, 17. So of our 3 numbers, the amide has to go. So I'm liking this one. It would resonate to the O- there. I like this one better. This would be the direct one, C. But the question says the most stable resonance form, and I like O- better than N-. These you took the wrong alpha, wrong position. That's a 20 there. I don't know what the nitrogen would do. It's talking about this one here. Wouldn't take it down to 17, that's for sure. $20. It's alpha to a ketone, isn't it? Same ballpark. So I'm liking choice D. And D, 17 is the pKa of the original. So pKeq, 17 of the original acid, 10 of the final acid. So KEQ is 10 of the closest to, 10 to the -7. There's your closest choice. Okay. I think this would be a good spot for our review of all new pKa's. You want to do the whole course? Why not? New pKa's in Chem 242. We had alpha to ketones. Or aldehydes, 20. We had alpha to esters, this ester or other carbox derivative was 25. There was a competitive interference with the resonance. We had amides. Amide, umlaut on an I. Don't see that every day. pKa equals 17. We had some new 10s as well. Alpha to 2 carbonyls. And we learned or alpha to 1 carbonyl, and maybe a nitrile on the other side. pKa is 10. 10. And what else do we have? Well, since it came up earlier, and it's also 10, sulfonamide, pKa 10. Extensive resonance with that sulfur there. I'm trying to think. I don't know if we have any other new ones from earlier. I know in our notes from previous sessions, we had another review page like this. If I missed something, go back to that one. Or chime in right now. And what we had our ylid precursors, since that's 242. We had like ooh. And our sulfur ylid precursor. Both pKa equals 30. Those are both ylid precursors. And since that came up, we had the phosphonate esters. And those were pKa 20. Kind of alpha to a ketone type things. That was the Arbuzov reagent. Oh, Arbuzov reagent. This page getting a little tall. Pretty good. And we got more lined up here. We had a particular request for this part of part 4 with sulfuric acid, 6 molar. Looks like things got a little cut off there. I can't remember what that says. Maybe we can figure that out together. This would be acid catalyzed hydrolysis of all carboxylic acid derivatives. That includes nitriles, carboxylic esters, and amides. It does not include ketones. You could make a good argument that 6 molar sulfuric acid has a lot of water present, and you could do hydration of the alkene and the alkyne, and I would be a very happy man. But for the majority of the points, I want you to do the hydrolyses of the derivatives of carboxylic acids. So I'll give you a couple answers. I'm going to put it outside the box. So I'll move it into the box when I'm done. So right here, I'm going to draw it down here. CH2, okay, and NH2CH3, you get an ammonium ion. And over here, we're going to get carboxylic acid, CH2, 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 COH, that's hydrolysis of an ester. And here's the other piece of the ester, CO2H. And what about CO2H? CO2H there. So the amide hydrolysis gave a carboxylic acid and an ammonium ion because the amine protonates. Ester hydrolysis gives carboxylic acid and alcohol. Nitrile hydrolysis gives carboxylic acid, and it didn't ask for this product, but if you're wondering where the nitrogen went, it's there. So I'm going to put that in the box. Oh yeah, this would be if the double bonds, okay. Don't do that. There. This would be if the double bonds didn't react. And I got a problem. Can't shrink that for the box without grouping it. Okay, be that way. I would also accept this answer here. I might give bonus too. If you got rid of the double bond and the triple bond, and hydration of an alcohol would give like an OH on one carbon and H on the other. Hydrolysis of an alkyne gives 2 new H's on here. This used to be an alkyne. I would accept that answer as well. I'd give probably 1 point bonus for the black additions. Because that's hydration of alkenes and alkynes. Alkene here, alkyne there. And since we're here, I can verbally go over what happens with lithium aluminum hydride. What happens is the amide becomes an amine. The carbonyl is now a CH2. Ester becomes an alcohol here. That will be a CH2OH. This will also be an alcohol. They will not be connected anymore. This will be an OH. Ketone is going to become an alcohol. New H there, new OH there. This becomes a CH2NH2. So that all that would go here. It's on the answer key. This question is, how do you reduce the alkyne, not the alkyne, the nitrile without touching anything else? And the pi bonds. H2PT. This was a verbal answer. This is H2 and PT. And how do you reduce the nitrile and the ketone without touching the pi, and without touching the ester, and without touching the amide, the lactam if you want to be picky? That's the one where you take advantage of sodium borohydride, being able to reduce aldehydes, ketones, and nitriles, and not the other ones. Don't forget to follow that with HCl every time. And I don't know what that says there. That's the only change. Well, that is the only change. We better look it up. Oh, ooh. I don't think it's an only change. It says CN. Sure, there's clues. There's only 2 letters. It didn't change. So the question is, how do you reduce an alkyne only to a cisalkene? That's a chapter 7 review item if I ever saw one. You can use Clemenson, which is zinc amalgam, and HCl. You could have used the old Wolff-Kishner. I'm a little worried about the Wolff-Kishner. The base that's present in that one might do hydrolysis of your ester. I would worry about that a little bit. Now this one down here it reduced all the carbonyls except for the one that's the easiest carbonyl to reduce. Aha! How do you do that? What did I just say? I was trying to tell you that using lithium aluminum hydride and HCl, the first thing that reacted there was the ketone. Then the derivatives. Well, it's clearly the same result. Verbally, I said you made an amine over here. Verbally, I said you made an alcohol here. And CO2H. That's a hydrolysis there, isn't it? Interesting. I don't know. I don't know if I can do this reaction. That's a bit of a typo right there. I mean, with the knowledge you know, I would expect you to be able to get there. Reduce all of the groups except for the ketone involves, you guessed it, protecting the ketone first. Favor protection of a ketone right here. Got an acetal. Then have at it with the reduction of every other group. And lithium aluminum hydride is always followed by acid, usually HCl, but I also want to deprotect my ketone, my acetal to get the ketone back. So just use H2O, SO4, XS, AQ. It's a twofer, you'll get both. And then what happened going from here to here is just the triple becoming a trans double bond. Apparently that semester I was trying to review chapter 7 a lot. Why don't I give you guys a heads up? For this page on your test, it's got to be smaller. Let's restrict it to reactions of reduction only. Yeah, so you're all sad about the whole thing she asked about was the hydrolysis. I'll put it this way. I won't do any alkyne-alkene reductions on your test. I'll have a hydrolysis. I'll put check marks on the things I like. I like this reaction for you on Wednesday. I like this one. I like this one. I like this one. This one, not so much. This one's good because it reminds us. There you go. And I won't do that one either. The alkyne reductions, not a fan. I mean, they're good, but we got to cut out some stuff somewhere. And I believe, how we doing? I didn't get anywhere near done all the stuff I wanted to get done, but it's kind of all we have time for. Anything you want me to close with today? Anybody? I had a request for more stuff. Here comes somebody.
Yep, I have a quick question.
Sure, my favorite.
1 second. So, like, can we get the list of the new BKEs we had?
We started over here, didn't we?
Oh, did we?
Right down here.
Oh, yep.
You want this one?
I'm sorry. Yeah, that's fine.
I don't know if it's comprehensive, but it's got a lot of them.
Okay.
So that would be on page 5 of today's Starboard notes.
Right. Okay, thank you.
You're welcome. And I sent you an email over the weekend. I hope 6:30 till 9.
Oh, Professor.
Yes?
Yeah, regarding this, we were hoping if we can do the test in our regular time, like from 2 to 4.
Oh, I think there's a couple students who can't do that.
Because like I think like most of us think that like 5:30 is, I mean 6:30 is too late.
I can try to move it back to 6, but I need to hear from the one student who had trouble with 6 before. If they could email me like right now and say 6 is okay or 6 is not okay, then I can go for 6 to 8:30.
Like even like, can you see that student if he can do 5?
I can't do 5. I'm pretty sure somebody's schedule prevents that. But that person who knows who they are, they'll email me today. And I hope they'll email me today. And I'll get back to you right as soon as I get some kind of response, okay?
Okay, thank you so much.
I don't think 5 is going to be doable, but we'll see.
So we're just hoping like the sooner is better.
I agree. I want it sooner too, but we got to be able to have everybody do it at one time, even if it's a little awkward for other people. Okay?
I don't have a problem with 5 anymore.
Yo, okay. What can we go 5 to 7? I'm going to email you guys right now saying, please, unless you have an objection, we're going to go 5 till 7:30. I still want to give you that 2.5 hours. So I'll email that right now because I don't want to take up video time. And I'll catch up with you guys on Wednesday. whatever time we finally agree on. And take care.